Imagine you're a tiny Arctic tern chick, just a few weeks old. You've never left the nest, but somehow, in just a few months, you'll fly 25,000 miles from the Arctic to Antarctica and back. You'll cross oceans, navigate storms, and land in a place you've never seen before. And you'll do it without a map, without GPS, and without anyone showing you the way. So how is that possible? How do animals that have never traveled before know exactly where to go? The answer isn't just instinct, it's a collection of invisible tools that most of us walk past every single day without noticing. Let's start with the most obvious question. If you've never been somewhere, how do you know which direction to go? For many migrating animals, the first tool is the sun. During the day, birds like pigeons and geese use the sun's position in the sky as a compass. But here's the problem. The sun moves, it rises in the east, and sets in the west. So if you're just following the sun, you'll end up going in circles. That's why birds don't just look at where the sun is, they also track the time of day. They have an internal clock, a biological sense of what time it is, and by combining the sun's position with the time, they can calculate direction. It's like having a sundial built into your brain. But what happens at night? The sun disappears. So nocturnal migrants, birds that fly under the cover of darkness, use something even more ancient, the stars. In the 1960s, a scientist named Stephen Emlin ran a fascinating experiment. He raised indigo buntings, small migratory birds, inside a planetarium. He showed them an artificial night sky and slowly rotated the stars. The birds didn't care which constellations they saw. They only cared about one thing, the point in the sky that didn't move, the center of rotation. In the northern hemisphere, that point is near the North Star. The birds learned to orient themselves around it. Even when Emlin scrambled the constellations, as long as there was a stable center, the birds could navigate. They weren't memorizing star patterns, they were finding the anchor. But here's where it gets stranger. What if there's no sun? What if the sky is cloudy and the stars are hidden? How do animals still know where to go? This is where one of nature's most elegant tools comes in, the Earth's magnetic field. You can't see it, you can't feel it, but it's everywhere. The planet is essentially a giant magnet with magnetic field lines running from the North Pole to the South Pole. And many animals, birds, sea turtles, salmon, even some insects can sense it. Scientists discovered this by accident in the 1960s when they noticed that robins in a lab would always try to fly in the same direction during migration season, even when they were kept indoors with no view of the sky. When researchers placed the birds inside a magnetic coil and reversed the magnetic field, the birds turned around and flew the opposite way. They were reading the Earth like a compass. But it's not just direction. Some animals can also sense the angle of the magnetic field. Near the equator, the field lines run parallel to the ground. Near the poles, they dip steeply downward. By detecting this angle, animals can figure out their latitude. They know how far north or south they are. It's like having an invisible GPS grid laid over the entire planet. For a long time, scientists had no idea how animals could actually detect magnetism. It's not like they have tiny magnets in their heads. Or do they? In some animals, like salmon and sea turtles, researchers found microscopic crystals of a mineral called magnetite in their tissues. These crystals align with the Earth's magnetic field, like tiny internal compass needles. In birds, though, the mechanism is even stranger. There's evidence that birds may use a quantum process in their eyes. Certain molecules in their retinas react to magnetic fields and create patterns of light and shadow that the bird can see. They may literally be seeing the magnetic field as a visual overlay on the world. It sounds like science fiction, but it's real. So now we've got the sun, the stars, and the magnetic field. But there's one more layer: landmarks. Animals don't just navigate using invisible forces. They also remember the world. Migrating birds learn coastlines, mountain ranges, rivers. Salmon remember the chemical signature of the stream where they were born. Whales may follow underwater topography, ridges and valleys on the ocean floor that guide them like highways. The first time a young bird migrates, it often follows experienced adults. But even when it flies alone the next year, it remembers the route. The combination of magnetic sense, celestial cues, and visual memory creates a kind of layered map. If one system fails, another kicks in. It's redundancy by design. And that's the key. Migration isn't one superpower, it's a toolkit. Different animals use different combinations depending on the environment, the season, and what they need. A sea turtle hatching on a beach at night uses the magnetic field and the brightest horizon. The open ocean reflecting moonlight. A goose flying south in autumn uses the sun, the stars, and the rivers below. A monarch butterfly, weighing less than a gram, uses the angle of sunlight and an internal compass to fly thousands of miles to a forest in Mexico it has never seen. They're all solving the same problem. How do I get from here to there when I've never been there before? The Earth itself is the map. The sun, the stars, the magnetic field, the shape of the land, it's all information. Evolution didn't give these animals a single trick. It gave them the ability to read the world. So the next time you see a flock of geese flying overhead or a butterfly drifting past in the fall, remember, they're not lost. They're reading a language you can't see, written in light and magnetism and time. And they've been doing it for millions of years.